Hello and welcome to Distributed Systems and Blockchain in the News. My name is Thomas Bocek, and today we have some interesting articles. First one is from Dan Lu. It's the following article here, and this article discusses the impact of web bloat on users with slow devices, emphasizing how advancements in internet bandwidth have somewhat mitigated the issue caused by web bloat and for users with slow connections, but not for those with slow devices. And this article details the challenges faced when using modern web platforms on low-end devices. This article argues that while internet speed has increased, CPU performance, crucial for web app responsiveness, has not kept pace, leading to poor user experience on modern websites for low-end devices. And he made some interesting tests. So he tested also with this device. It's a mobile device, Intel P32. It's the following device here. It was released in 2018. It has a low resolution display. It has 1 GB memory. It has 4 cores, rather low clock speed. So it's a low-end device. And if we go here and see how, for example, Reddit is doing, he couldn't do any measurements with Reddit, also not with Discourse and Shopify. And these numbers show how long it takes. So the LCPU and the CPU, how long it takes to see the first content. So LCPU is the first content, and LCPU, what it is the largest contentful paint measures when a user perceives that the largest content of the page is visible. So this is the first number, and the second number, how long the CPU was busy. And well, there are sites that take rather long, and some sites also fail, meaning that they're currently inaccessible for low-end devices. The next article is this one here. It's about passkeys from Kudelski Security. Passkeys, also known as FIDO credentials, FIDO stands for Fast Identity Online, are a type of authentication method that uses WebAuthn standard. And they are designed to be phishing resistant and server breach resistant, and can be used to authenticate users without the need for traditional passwords. The main advantage of passkeys over traditional passwords is their security. They are encrypted and stored in a secure location, and the private key is not accessible to the server where you're logging in. And this makes it more secure than traditional passwords. However, some passkeys also have limitations. Some can only be used on specific devices, as for example, where they are created. And if a user wants to use a passkey on a different device, they will need to create a new passkey on that device. And this is a limitation that can be mitigated either by using hardware security keys, which can be used on multiple devices, or with the possibility of exporting the private key. And in terms of implementation, passkeys are typically handled by browser extensions. And this is also what they were looking into. So they are describing how it works, and also how it works with Bitwarden, which is an open source implementation that also supports passkey. And what happens is when a user tries to log in to a website that supports passkey, the browser extension intercepts the WebAuthn calls and handles the passkey creation and authentication. And the threat model for passkeys, they differ from that of hardware security keys. And with passkeys, the private key is present in the user system at some point in time, potentially accessible to an attacker. It's somewhere in memory because it needs to be used to sign certain messages. However, the private key of passkey in some devices is not easily exportable. They explain it also here with Windows, for example. And that means if a user wants to use a passkey on different devices, they will need to create a new passkey on that device. This article also, as I mentioned, looks into the Bitwarden password manager, how the passkey is implemented. And this allows users to save passkeys in the Bitwarden vault and synchronize them to other devices. And the Bitwarden browser extension intercepts those calls, displays a pop-up to save the passkey in the Bitwarden vault, and the passkey is stored encrypted in the Bitwarden vault and can be exported to another device. And passkeys offer interesting alternative to traditional passwords, providing better security and resilience to phishing and server breaches. However, the threat model for passkey needs to be assessed according to the specific use cases. Very interesting article, and also very detailed on how the messages look like that are sent from the server to the browser extension. The next article is about HTTP 2 and HTTP 3, and both versions, HTTP 2 and HTTP 3, are versions of the Hypertext Transfer Protocol, HTTP, which is the foundation of data communication on the internet, on the World Wide Web. And these versions have different features and improvements compared to their predecessor, HTTP 1.0. And he also starts with 0.9 and 1.0, and also goes over to HTTP 2 and here HTTP 3. And HTTP 2 introduces several improvements: multiplexing, header compression, stream prioritization, multiplexing that allows multiple requests and responses to be sent over a single TCP connection, reducing the number of round trips and improving the performance. Header compression reduces the size of HTTP headers, which can significantly also improve the performance. And stream prioritization allows prioritizing certain requests over others, improving the perceived efficiency and resource allocation. And HTTP 3, on the other hand, it's a successor of HTTP 2 and is designed to address some of the limitations that were present in HTTP 2. And it provides, or it uses the quick UDP internet connection. It's a new transport protocol built on top of UDP, and Quick provides features such as connect migration, connection resilience, and improved performance. It also includes features like connection IDs and zero round trip communication, which allows for faster and more reliable connections. And this article mentions that HTTP often outperforms HTTP 3, which I tried to verify. It's somewhere down here. On reliable and stable connections, HTTP 2 many times offer better performance than HTTP 3. I tried to look into some benchmarks and I found the following here. Need to load the page. So the following here, they did some benchmarks here. They showed that, for example, for smaller test pages, HTTP is faster. Here, a couple of milliseconds faster than HTTP 2. And for larger, HTTP 2 is somewhat faster. So 2.3 seconds versus 2.33 seconds. So not by a lot. And there is another benchmark, the following here, quite extensive benchmark, and he also compared HTTP 2 to HTTP 3 with different scenarios, which is quite nice. And he also has a conclusion. his conclusion is HTTP3 is not as big as a step forward as HTTP2 was over HTTP1 in terms of performance boost. And in those scenarios where HTTP3 tried to fix what HTTP2 did wrong, they are of course better. And he also argued that for mobile networks and unstable connections, HTTP3 is better. The last measurement I found here, and here he concludes, where is it? We saw substantial higher throughput on HTTP3 compared to HTTP2. So here is the table, and we see that HTTP3 always had a higher throughput. So I think this conclusion needs a bit more refinement. And he also mentions here zero round trip enables replay attacks and therefore is unsafe. In theory, this is correct. However, when he refers to replay attacks, to my knowledge, this only works if the key material is leaked, because you can only do a zero round trip connection if both have the key material already from each other. And I would argue that if your site is leaking key material, you have bigger issues than a replay attack. And but I like the overall conclusion. It's important to note that the choice between HTTP2 and HTTP3 depends on the specific requirements of your application and the characteristics of the network environment. It's recommended to run compatibility and performance tests to determine which version is the most appropriate for your use case. Additionally, a server can support both HTTP2 and HTTP3 connections, allowing the client to choose the version that best fits their needs. The next discussion is about terminal latency. It's the following here. And specifically, this article is about how the terminal emulators, how fast they can show from a key press to a character on the display. However, everything was in software, so the key press was emulated, and also the measurement of if something is changing on the display was also measured by software. The author was using Xterm for a long time and has noticed that Xterm Unicode support is broken, and that made him look into other alternatives. And the author tried other alternatives, other terminal emulators, and found some of them. So these are the terminal emulators he were looking into. So here, Xterm, Alacrity, KittyTune, Zotti, ST, and console, Kitty, Westterm, GNOME terminal. Most likely, I'm sure I'm using GNOME terminal, XFC terminal, Terminator, Tilix, Hyper, and many more. So the fastest one he measured Xterm, and probably I'm using this one. I didn't notice any drawbacks, but the author also mentions he types with 80 to 120 words per minute. I'm not that fast, so probably I didn't see a difference when using GNOME terminal. And the interesting point here is that while he was testing it, he was publishing, and some of the authors of this terminal emulator here, ST, they actually replied and said, hey, generally speaking, there's a trade-off between latency and throughput. So the smaller latency, the worse the throughput is. And they also made a version specifically for this problem to have very low latency and not caring about throughput. And he updated this article, did some new measurements, and figured out that ST is actually quite fast. So that's the version he measured before, and that's after the patch. And we see it's even faster than Xterm when you specifically tune the performance for latency. And this should also give you a hint of how fast 5 milliseconds is, or the latency, what it means. If you have a 5 millisecond on network latency, what would it mean for the display? It means the characters in this scenario now on the terminal, when it's transmitted over the network, it would mean that the latency will double from 5 milliseconds to 10 seconds to 10 milliseconds if we add another 5 milliseconds delay. That's just to get a feeling of the latency. The next article is about Ahrefs. I'm not sure how to pronounce this company. It's the following article here, and the title is How Ahrefs Saved 400 million US dollars in 3 years by not going to the cloud. This explores the cost implications of cloud versus on-premise data centers. So they have on-premise, and they calculated how much it would cost with AWS. And the author begins by acknowledging the popularity and the benefits of cloud infrastructure, such as flexibility and ease of scaling, but also highlight the significant costs that come with it. And Ahrefs conducted a detailed comparison between their on-premise data center in Singapore and the equivalent setup in Amazon Web Service with AWS, using specific hardware and cost structures to illustrate their analysis. This is their server rack, or one of their server racks, and here they calculate the cost for one server, and the corresponding AWS cost is roughly 10 times as much. So here we have 1,550 US dollar per server, and here we have 17,575 US dollars per server. And Ahrefs, they operate with high-end specifications, and they have optimized their expenses based on a 5-year usage period for their hardware. So after 5 years, this cost you see here, after 5 years, the server, they will get replaced. So the appreciation goes over 5 years. And they calculated their monthly cost considering factors like rent, electricity, internet services, and revealing that their on-premise setup incurs significantly lower cost compared to an equivalent setup in AWS. Specifically, the cost of running 20 Href servers on-premise would equate to the cost of approximately 2 servers in AWS, and over 2.5 years, for in total they have 850 servers. The estimated additional cost for using AWS would have been around 400 million US dollars. However, in his calculation, he did not include server maintenance. On the other hand, for 850 servers and a budget of 400 million US dollars for server maintenance for 2.5 years, you could hire 500 engineers with a 320,000 salary per year to reach the same cost as with AWS. And the last article is from the crypto world. It's the following article here. This last article criticizes the EU Parliament's approval of strict anti-money laundering laws, which includes banning anonymous cash payments over 3,000 euros in commercial transactions and completely prohibiting cash payments over 10,000 euros in business transactions. Additionally, anonymous cryptocurrency payments to hosted wallets are banned without a threshold. And the member of the European Parliament, Patrick Breyer, he argues these measures infringe on financial freedom with minimal impact on crime, emphasizing the importance of privacy in transactions and an increased bank dependency. It's the following article here from Patrick Breyer. He's from the Pirate Party, and Other sites report this as well, that self-custody wallets now become illegal in the EU due to this new anti-money laundering law. That means that wallets that support self-custody, where you have your wallet with your private keys under your control, this may become illegal in the EU. So let's see how this change of regulation evolves, and I'll keep you updated.